Hello, welcome to my video. Today we are going through worksheet 3 of the trigonometric ratio chapter. Alright, so without further ado, let's start. 2a, question 2a. Okay, we are given two lines this time. Alright, then we're supposed to find x. Okay, the given line is opposite of x, and this is hypotenuse. Okay, so O and H will give you sine. Okay, so sine x degrees equals to 10 over 17. Then we are going to bring the sine over. When you bring sine over without the number in front, okay, the number at the back, okay, be it a ratio or the degree, the angle, okay, if you're not bringing this, you're only bringing sine alone, it will turn into something called sine inverse. Okay, this has to do with your indices, but if you've forgotten, it's fine. Just remember that if you're only shifting sine alone, okay, to the other side of the equation, then you have to apply an inverse. Okay, this is inverse minus 1. Okay, you can see this in your calculator above the sine button. Okay, it's above the sine button. All right, so it's like you have to press shift sine to get to apply the sine inverse function in your calculator. All right, next, key in this into your calculator and you should get 36.0, okay, degrees. This will be 1 dp, 1 decimal place, because it's angle. All right, next, B. Okay, we are given line AB. Line AB is adjacent to my x degree. My x degree. Okay, and line 90 cm is h, my hypotenuse. So we have A and H. So that is car. So cosine x degrees equals to A over H. A is 63 and H is 90. Then leaving x, make x the subject. So we have cosine inverse 63 over 90. Key into your calculator, it should be 45.6 degrees. 1 dp. All right. Next, moving on to question 4. There's no question 1 because I took this out from another book. All right. So question 4a. We are to find two angles. The first angle is over here, and first angle is x, is over there, and then the other angle is y. Okay, so this is an isosceles triangle, so therefore this is 29 as well. The line over here in the center would cut the base into two equal sections as well. So therefore, line CD equals to line BC equals to 36 divided by 2 equals to 18. So let's label 18. Now we have two angles, okay? Two lines. Then we can find the missing angle. Okay, this would be hypotenuse. This would be adjacent. Okay, so cosine again. So 18 over 29 equals to cosine x degrees. So cosine inverse 18 over 29 equals to x degrees. All right, then therefore x degrees equals to 51.6 degrees, 1 dp. All right, next we are supposed to find y. Okay, y is the same as this angle. Okay, so we're going to use this angle. This is y. Then how to find y? We have these two lines again. Use the same two lines. Okay, in this case, y 18 is my CD is opposite of y, so instead this one is no longer A, this is O. O and H is sine, so sine y degrees equals to 18 over 29. Then y degrees equals to sine inverse 18 over 29 equals to 38.4 degrees. Okay, 1 dp. All right, so this is the answer for A and B. Sorry, part A only. Okay, next, moving on to 4B. All right, let's see. We are supposed to find this angle, this line BC, which is x. We notice that down here, this is isosceles, so and this is 90 degrees, so therefore this angle will be 45 degrees. Why? So angle BCD equals to 180 minus 90 minus this angle, then divide by 2 equals to 90 over 2 equals to 45. All right, degrees. Okay, so BCD is 45 degrees. This is a hypotenuse, and then my x is adjacent. So using cosine again, so BC over 44.1 equals to cosine 45 degrees. Then BC equals to, oh wait, BC is x. I can replace it with x. Okay, so x meter equals to 4.1 cosine 45 degrees equals to 2.903 SF. All right. Next, we are going to find y. Okay. Since x is this length, wait, I need my 5SF. So for 5SF is, because I'll need to use x later, so 2.8991. Okay, this is 5SF. All right, so I will need this in my next equation. This is 2.8991. Then I have this two line. I need to find y. Okay, this line, my BD is opposite. Okay, my AD is hypotenuse. So O and H is sine. So sine y degrees equals to opposite, which is 2.8991 over 5.9. We do not use the 3SF because it's not accurate enough, so we use the 5SF, all right, in our working. So y degrees equals to sine inverse 2.8991 over 5.9 close bracket, okay, equals to 29.43 SF. So this is answer. Sorry, this is not 3 SF, this is 1 dp because it's angle. 1 dp. Alright. Okay, let's move on. 5. Question 5 is a question without a diagram. Okay, you can, however, sketch a diagram so that we can identify what they actually want. Okay, so let's draw ABC. They did not say that ABC is a right angled triangle, so it's okay. I'm going to just draw a random triangle and label it A, then B, then C. It says that the area is 2.4 meter square. Then AB is 1.9, 1.9. Then it says the shortest distance from A to BC is 1.5. What does this actually mean? It means that if I were to project down, okay, the shortest line down to the line BC as a whole, okay, this line is 1.5 and it has to be the shortest line. Okay, so what kind of line would be the shortest? Okay, let me just take some time for example. Okay, so imagine if I draw a line right now here. Okay, this is a straight line. Okay, now look as I move my line closer towards the center until it reaches the bottom, okay, of point A, right? Directly bottom of point A, you realize that this is the shortest already. As I move over to the other side towards point C, right, you notice that the lines start to grow longer and longer. So where is the shortest line? The shortest line is over here, okay? And this short line, right, will form a right angle, okay, a right angle with line BC. So whenever you see the shortest distance from one point to the line, they're asking you to draw a perpendicular line from the point to the line, okay, like this. Okay, now after I draw this perpendicular line, I'm going to name the other end of the perpendicular line M. You can also name it X or whichever alphabet you like lah. Okay, but for now let's stick to M. All right, because it's in the middle, so-called middle of B and C. All right. Now, so we have AM. Do we have angle? Find angle ACB. ACB, this angle over here. Okay, so what to do? Okay, let's find out what is this length AB. Can we find out what's the length AB? Oh, we cannot. Not yet, actually. Let me think. Oh, right, they have given us this AM 1.5. What am I doing? Okay, so I have this line. So I have area. Does it mean that I can actually find what is BC? Yes, I can. I can find what is BC. Okay, so I can find BC how? Okay, area of triangle, okay, equals to half times base times height. This is my base, this is my height. I am given the height, I'm looking for base. I am also given the area as well. So I can just throw in the numbers. So 2.4 meter square equals to 1/2 times base is BC, then times height is 1.5 meter. Okay, then just let's work out half times 1.5 equals to, so equals to 0.75 BC, right? So 2.4, then I will have to divide both sides with 0.75. So 2.4 over 0.75 equals to BC. So therefore BC equals to 3.2. Okay, so this is 3.2. And once we have this line, and we have this line, I can find this. Can I? Not yet. I cannot. I need to find what is this BM first. Then after that, I need to find what is this line, because this is not a right angle, right? They did not tell us it's a right angle triangle. So we cannot assume. Do not assume. Okay, so let's find BM first. Okay, to find BM, since I have this line and this line already, I can use Pythagoras theorem to find BM, because BM square plus AM square equals to AB square. Okay, so it is basically this formula: C square equals to A square plus B square. This C square, the C is my hypotenuse. Okay, then this A and B is the two perpendicular line. Okay, perpendicular lines. Okay, perpendicular lines of the triangle. Okay, so BM square plus 1.5 square equals to 1.9 square. Okay, so all these numbers are taken reference from the triangle over here. Okay, so I'm going to make BM the subject. So BM square equals to 1.9 square minus 1.5 square. Okay, what will I get? It will be 1.36. Okay, then BM equals to square root 1.36 equals to 1.1662. Okay, phi as F. Okay, and this will be 1.1662. All right, next I will need to find this CM or MC, up to you. Okay, so CM equals to 3.2 minus 1.1662 equals to 2.0338. Okay, this is 5SF. Okay, so 2.0338. Then with this, we can find, with this information, I can find this angle already. So over here, this is my adjacent, and this will be my opposite, right? Okay, so adjacent and opposite. So I have adjacent and opposite, so I can use tangent. So tangent, let's call this angle ACM or ACB equals to opposite over adjacent, which is 2.0338. Then angle ACB equals to tangent inverse 1.5 over 2.0338. Close the bracket, equals to 36.4 degrees, 1 dp. Alright, angles always give the answer in one decimal place. Okay, if you found an angle and you're going to use it for working, then reduce it to round off to 3 dp before rounding off to 1 dp. All right, so this is the answer. Okay, for 5. Let's move on to the next question, which is 7. Okay, so down here I have a diagram. Okay, so diagram shows a kite ABCD, and AB is 37 cm. Okay, the length of the diagonals AC, BD are 60 and 65 respectively. This is not listed inside the diagram, so we have to do it ourselves. Okay, so AC is 60, so let's label 60 close to the line, and then 65 is BD, which is this one, 65. Okay, we also know, okay, so we also know that the diagonals, right, of the kite cuts each other, cuts this line, okay, this AM, right, cuts this BD equally. Okay, so we can actually find out what is MD, okay, or BM. All right, then next, AC and BD intersect at M such that CM is 43 cm. So that means here is 43 and here will be 60 minus 43. Okay, we can find that later. Okay, let's just keep that in mind. By finding angle ABD, okay, where is ABD? ABD is here by finding this angle, okay, and angle DBC. DBC is this angle, okay, use a different color, okay. Determine if if the angle ABC is a right angle. Oh, so basically to check whether if this is a right angle, okay. So let's see, how should I do this? Let's find BM first. Okay, so BM equals to 65 divided by 2 equals to 32.5. Okay, so this is 32.5. Then we should find AM. So AM equals to 60 minus 43 equals to 17. 17 is over here. Then, now we have one line here and one line here, so I can find what is this angle, right? Okay, let's find what is ABM. Okay, so ABM would be ABM. I'm spoiled for choices because I have all three lines here. Okay, so ABM. Let's use the adjacent and the opposite. Okay, so adjacent would be we have O and A, so tangent. Okay, we're gonna use tangent, right? O over A equals to tangent angle ABM. Okay, and O is opposite 17, adjacent is 32.5. So angle ABM equals to tangent inverse 17 over 32.5 close bracket equals to ABM is 28.553 degrees, 3 dp. Okay, next we are going to find my what angle? DBC, this angle over here. Okay, so we have this angle, this line, and we have this line. Okay, 32.5 and 43. So this angle, this is adjacent. Let me just label that adjacent, and this would be opposite. Okay, so same thing, opposite and adjacent gives me tangent. So we can use tangent to find. So opposite is 43 and adjacent is 32.5 equals to tangent, then angle CBD. Okay, then make CBD the subject, equals to tangent inverse 43 over 32.5. Okay, key into calculator, you should have 52.9183 dp, all right, degrees. Then finally, we are going to check whether if it's right angle by adding them together. Okay, so 28.553 plus 52.918 degrees equals to 81.5 degrees, 1 dp. Okay, this is so far off from 90 and therefore is not equals to 90 degrees. This is not equals to. So my answer, therefore angle ABC is not a right angle. Alright. Lastly, let's move on to question 10. Oh, that's not the last. We still have 11. Okay, so let's move on to question 10. So for this question, you need to draw a sketch of the right angled triangle first. Let's draw the sketch. Okay, then we have this statement that says that OA is to AB is 7:4, and OA is the longer side of the triangle. So this tells us that OA is the hypotenuse. Okay, then the next point, this will be B. Okay, so 7:4, so we say that OA is 7x, and then AB is 4x. Okay, with this information, right, just from this information, we already have a trigonometric ratio already. All right, then down here the questions asked, okay, so let's see, triangle OAB is rotated about the point O to form triangle OA prime B prime, such that AO A prime is a straight line. So that means, wait, let me just shift this triangle. That means that when I rotate my triangle, let me duplicate this. When I rotate my triangle, right, it will become this in such a way, okay, that the new triangle, which has called A prime and B prime, right, this A to point O to point A again is one straight line. This is what they're trying to say. Okay, so let me get rid of some of the lines or some of the points and rewrite some of the points first. Okay, so this is 7, this is 7x, this is 4x, this is B prime, this is A prime. Okay, then let me shift the O so that it's a bit more visible. Okay, so this is the triangle, or rather this is the image, okay, the figure that that they want from us. Okay, so with this, let me shift this a little bit, at the same time make this a bit smaller. Okay, let me shift it over here. Okay, then they are asking for find the obtuse angle A prime then OB. Okay, so they're asking for A prime, oops, let me use a highlighter, A prime O then B. They're asking for this particular obtuse angle. So how to find this obtuse angle? Okay, if this is the straight line, right, does it mean that if I can find this angle, right, then take 180 degrees minus this angle, then I'll get this obtuse angle, correct? So let's find what is this angle. This angle is angle AOB. Okay, now we have the hypotenuse. We have this line is opposite. Okay, opposite my angle. So we have sine angle AOB equals to hypotenuse, which is 4x, over sine, which is 7x. Okay. Then when I rearrange it in this manner, okay, the x would cancel out each other, leaving behind only 4 over 7. Okay, then I can bring over my sine. So angle AOB equals to sine inverse 4 over 7 bracket, then equals to, which is 434.84 50. Okay, so this is 3 dp. Okay, degrees. Then take 180 minus 34850 degrees equals to 145.2 degrees, 1 dp. Alright, so this is the answer. Okay, so next, moving on, is question 11. Okay, so in this question, it says that the diagram shows a circle at point 0, a center at point 0, and then the radius is r unit. So center, and then we have the radius. Okay, there is a rectangle PQRS is inscribed in the circle. Okay, so PQRS is inside. Okay, then RS equals to 1.9 R units. Then they're asking us to find ORQ. ORQ. They ask us to find this angle, right? So let's zoom in a little bit. Okay, now if I were to draw a line over here, okay, a parallel line, okay, to this point, then this point, okay, is perpendicular to my QR, and I form a right angle triangle. And it's quite obvious that down here, okay, if I were to draw the line, let me draw the line, okay, this perpendicular line, right, would cut QR equally, okay, into 2 points, okay, and also down here we know that O to this point, let's call this point M, so it's easier to refer to. So point QM, okay, is actually half of this line, okay, SR. So first, let's say OM is equals to 1.9 R divided by 2, which is equals to 0.95 R. Okay, so with that, let's label it 0.95 R. Okay, and down here, this is R. So we are supposed to find this angle. Okay, this is my hypotenuse. This R radius is my hypotenuse. And then my 0.95 R is my opposite. Okay, so opposite and hypotenuse, I can use sine. So sine angle ORQ is equals to 0.95 R over R. Okay, then down here I can cancel out my R, and this is replaced with 1. So angle ORQ is equals to sine inverse 0.95. Okay, and that would give us 71.80 degrees, 1 dp. Okay, so this is how you find part A of the question. Okay. Next, let's look at part B. So for part B, we are supposed to find, or rather, we're supposed to show that the area of the rectangle is about 1.19 r square units. Okay, so for rectangle, it's just length times breadth, and since we already have this length over here, we just need to look for the breadth. Okay, so in this case, how do I find the breadth? We have this line, we can simply use Pythagoras theorem, okay, to find RM or MR. Okay, so let's write down the base formula. So OR square, which is the hypotenuse, equals to MR square plus OM square. Okay, then OR is R, and square equals to MR is 0.95 R square, bracket square. Okay, then plus OM square. Okay, then let's make OM square the subject. So we have OM square equals to R square minus bracket 0.95 R bracket square. So one question that you may have is, why do I need a bracket over here? The reason being, if I write 0.95 R square, this square only belongs to R. Okay, it does not apply to 0.95. So we need to make sure we have the 0.95 included, okay, by adding the bracket. Okay, next step is to find out. So I'm going to just write R square minus 95 square equals to 0.9025 R square. Okay, so R square is just 1 over here, so I'm going to take 1 minus 0.9025. Okay, So it'll be 0.0975 r square. So om square. Then I want to square root, so om equals to square root 0.0975, okay, r square. Okay, so just need to square root the numerals. 0.0975 equals to, oh, this is a huge number, 0.31225, then R 5SF. Okay, now I'm going to, this is OM, and then QR, right? Oh, sorry, OM. Did I just write OM? Oh no, I have mixed up the number, so this is not OM. Let me just rewrite this. This is OM, but OM is the given line, so down here should be MR. And this should be MR as well. This is MR. And this is MR. Okay, then once I have MR, I will times 2, okay, to get QR. So QR equals to 2 times 0.31225R equals to 0.64624, then 50R. Okay, then we have my QR. Then I will take QR multiplied by SR, so 0.62. Oh wait, let me label first. Area equals to 0.62450R times 1.9R equals to 1.18655 r squared, then approximately 1.19 r squared 3SF. And then we can write down shown. Okay, so this is how you do question 11. Okay, and that is all for this tutorial. Thank you for watching, and I will see you in the next one. Bye.